Okay, so in chapter 5, we are going to talk about special segments in triangles. Okay, so the first definition is perpendicular bisector. So perpendicular bisector has the meaning of it right in the word. Perpendicular obviously meaning that it forms a 90-degree angle, and bisector meaning that it's splitting the segment in two congruent pieces. So perpendicular bisector is a line, ray, or plane that is perpendicular to a segment and splits it into two congruent parts. Alright. Equidistant just means the same distance. Equi again meaning equal. Obviously you know what distance is. So equidistant meaning two things are the same distance. So the first theorem is the perpendicular bisector theorem, which says that if a point is on the perpendicular bisector, so for instance we're giving you that this line CP is the perpendicular bisector. Any point that I draw on here is going to be the same distance back to A as it is back to B, okay, no matter where that point is. So no matter what point I pick, it's going to be the same distance. Okay, and again, any point. The converse, and again we know kind of that a converse isn't necessarily always true, but in this case it is. So the other theorem is the converse of that, which says that if a point is the same distance, so if I can say that this point right here, we'll call it point E, is the same distance back to A as it is back to B, then that point E must be on the perpendicular bisector. So again, very subtle difference. Just saying, in the first case, I'm telling you that the line is the perpendicular bisector, so you can assume that the point is equidistant to the two endpoints. In the second theorem, we're saying that if the point is equidistant, then we can assume that it's on the perpendicular bisector. Okay. So in example 1, we want to know what segment lengths are equal. All right. So we have that MS and MT are equal. Right? And that's because M is on the perpendicular bisector. Okay? And also, we're told that QS and QT are both 12, so we can assume that those are equal. And skip the first one here, which is that NS and TS are equal, and two reasons we know that. One, it's marked in the diagram by tick marks, and two, because it's on the perpendicular bisector. Again, bisecting meaning splits this into two congruent parts. How do we know that point Q, if this were extended, would be on that perpendicular bisector? And that's because these two segments are congruent, and if they're congruent, that means the point must be on the perpendicular bisector. Oops. All right. The next this is just a definition that we're going to use in the angles bisector theorem, okay, which is that when we're talking about the distance a point is from a line, we're talking about that shortest distance, in which case we would be describing this distance JP, and the way we find that is by drawing a perpendicular line from your line back to the point, okay, and that's going to give you the shortest distance. Okay. So in the angle bisector theorem, if a point is on the angle bisector, so bisector, of course, would be this ray that splits the angle into two congruent parts. Okay. If it's on that point, so for instance point D, then it's the same distance from D back to C as it is D to B. So these will be congruent. Again, the converse says if those lengths are congruent, then we can assume that this is the the angle bisector. Okay, so again, just given what information you have, you can draw a different conclusion. And if point D is on blank of segment AB, then D is equidistant. Okay, so it'll be on the perpendicular bisector. Okay, if point G is on the interior, so for this one we can draw a picture of angle HJK, and it's equidistant back to each point. What can we conclude? And that would be that point G is on the angle bisector. Alright, in the diagram, line CD is a perpendicular bisector of line AB. So what is the relationship between AD and BD? And it would be that they are congruent. And what is the relationship between angle ADC and BDC? And they would both be 90 degrees because it means that that is the perpendicular bisector. Okay, lastly for this section, 6 and 7. Alright, what is the relationship between angle LPM and NPM? So LPM, so because this is an angle bisector, they would have to be congruent. How does the distance between point M and right PL relate to the distance between point M and line PN? And that will be that they are congruent. Okay, and that's all there is for this section.